Okay. So the mole. The mole is not like a dark spot on somebody's chin or a funny little animal that lives around with very, very small eyes. I don't exactly know why it's even called a mole, but this is what it's called, it's the mole. So we talked about knowing masses of protons and neutrons and knowing how many we have. And so with this one piece of key evidence, it really unlocks the door for working out quantities in chemistry. Because if the mass of one carbon-12 atom is 1.993 times 10 to the minus 23 grams. Okay, so this was found experimentally. Somebody had to devise a way of measuring it. And this is a very, very small number. Hopefully you know that what we're talking about doing there is we've moved that decimal place back 23 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That's how small the number is. Okay. So that is very, very small for one carbon atom.
That's 1/12 of the die?
No, this is one atom.
Oh, okay.
So this one has then, if we would have to divide this by 12 to find the mass of the individual protons and neutrons in the atom. Okay, so this is one atom. But our definition of carbon-12 is that if we want to know how many atoms in exactly 12 grams. This is what we needed to know. So how many atoms in exactly 12 grams of carbon-12? And it is 6.02 times 10 to the 23. Okay, so this tells me how many atoms are in 12 grams. So if I multiply these two numbers together, I would get 12, wouldn't I? If this tells me how many there are, and this tells me how much each of them weighs, then I should end up with the mass of
Where did you get the 6 from?
Where did I get the 6 from?
6.02.
So this number here is how many, this is the number of atoms of C12 in 12 grams. So these two numbers together multiply to give me 12. Or if I divided 12 by this number, I would get this one. 9. Try that.
But I thought you were doing one. How come 1.993? Well, yeah, how come those numbers swapped? That's what I was getting at.
Sorry?
Up in the top when you've got the mass of...
That's one atom. That's the mass of one atom. Now we can't really, this is a very difficult mass to weigh in the lab. And it would be really hard to see a chemical reaction, a occurring with just one atom. And so what we want to know, well, how many atoms then are in 12 grams? So if each atom weighs that, and I want to find out how many atoms there are in 12 grams, I would divide the 12 by that, and it gives me this there. That's the number of what? That's the number of atoms in 12 grams of carbon 12. Does that make sense? Okay. And we call this number Avogadro's number. Sometimes this is called Avogadro's number.
I was just thinking that.
Avogadro's constant. This is a very, very important number. And it's on your formula sheets.
So 12 grams equals Avogadro's number times by 1.993.
That's exactly right.
Okay.
Yes.
Right.
That was the way I explained it to start with, and then I went the other way. But we
Okay.
got there in the end.
Right.
So that's all that matters. These two multiplied together
Yeah, because I was,
will give us 12 grams.
you didn't calculate 6.02, that was just given to you.
Yeah,
That's-
I just
yes.
showed you where it
Yeah.
came from.
Okay.
Yeah. So this way, this calculation shows you where it's come from, but this also shows you the relationship between them.
Right.
Okay? So we call this then, this number of particles, this number of atoms, that's 1 mole. And for reasons that remain a mystery to me, we actually shorten mole to MOL.
Yeah, that's
Because, you know, it's really hard work writing that E. So mostly it is a mole, but we'll be writing it this way. Now, one way you can think of it, you can have a mole of anything. You can have a mole of chairs, you can have a mole of students, you can have a mole of grains of rice, you can have a mole of anything. A mole is just a number. In the same way as if I've got 12 eggs, most people would have no problem at all saying, well, that is 1 dozen. Yeah, dozen eggs. So it sort of makes sense. You buy the eggs by the dozen or the half dozen or whatever. So that's how the eggs come sold. When we're talking about doing chemistry, we really want to be able to use masses that are easy for us to handle, and so we can't really do chemistry with individual atoms. And so we want more. We want to make sure we've got enough particles to react with to be able to do our chemistry. And so this many is the equivalent of 1 mole. And like I said, it could be anything. It doesn't have to be atoms, because it's just a number. And just like this doesn't have to be eggs, it could be potatoes or whatever. It doesn't really matter. It could be bread rolls, which we also seem to buy in dozens. Or
But the baker doesn't.
a baker's dozen has 13 in there, because bakers can't count, apparently.
So That 6.02 times 10 to the power 250, that's a very big number though.
It is a very big
It's
number.
like that number but opposite.
Yeah.
So that's a lot of bread rolls to have a mole.
If we had a mole of bread rolls, we would never go hungry again.
Okay.
If the world had a mole of bread rolls, that would go.
Look, I don't even think the world. I think
Has
if we had a
produced a
mole of
mole.
bread rolls, we would be drowning in bread rolls. If we covered
have enough.
How about,
That'd be pretty good.
how about a mole of donuts?
You get mold down.
Now it makes
That was a good one, Bria.
Thanks.
it makes sense that this has to be a big number because this one is a very small number, and when we multiply them together, we want to come out pretty well even, don't we? And so because these masses of individual atoms are tiny, 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 then we need a big number to bring them up.
So pretty much, take out the 10 and 23s, it's basically just 6 times 2 equals 12.
Yeah.
Around.
Yeah, that's right.
So why don't we use this number then? It'd be way easier without it.
But then, like,
Because that's not, because one atom doesn't weigh 2 grams. If it did weigh 2 grams, then we could totally get rid of those powers and it would be very simple, but that's not how it works, so we can't do that.
So, I understand what you've done so far, but I'm a bit confused in the sense of like, how many, like, why 6.02, why is that 1 mole? And what does 1 mole represent? Is that like that many singular neutrons or protons in a mole?
Now, we call it a mole, or we say that this many particles of any description is equal to 1 mole of that particle. So we're not specifically talking about subatomic particles, we're not talking specifically about atoms or elements or compounds even. This is just as variable as the dozen is for, you know, like we can say a dozen eggs or a dozen potatoes or a dozen bread rolls, and everyone understands that if I say a dozen, I mean 12. So I can say 1 mole, I've got 1 mole of carbon atoms, say, and everybody should know that what I mean is I've got 6.02 times 10 to the 23 carbon atoms. If I said I had 1 mole of cars, then everyone should understand that means I've got 6.02 times 10 to the 23 cars.
Hang on. Surely it's not 6.02, blah blah. Sure, it's not that number of cars, it's that number of particles of the car.
No, no, no. It's
It's that
that
many
many
cars.
cars. So if I have a mole of cars, I have that many cars.
That's going to use a lot of petrol. That's going to use a lot of petrol.
That will use a lot of petrol. Not only that, just say I have a mole of cars.
They're the richest person ever. Yeah. You super with the richest person.
Okay, so there is my mole of cars. I have 1 mole of drivers. Oh, hang on. I have 1 mole of drivers. I have 4 moles of tyres. Okay, I've got 1 mole of steering wheels. I've got 2 moles of headlights. So if I wanted to work out how many tyres I have, I'd have to multiply that by 4. So I had a big number and now I've made it even bigger.
So a mole is carbon atoms, right?
A mole is just a number, a big number, that we had to be able to measure carbon atoms to work out the size, if you like. And if I want to know how many atoms I have, exactly 12 grams of carbon, and this is how much each atom weighs, then that's how many I have. It's a very big number. But now that we've got this number, we're going to call it a mole, and we can use it then for anything. So 1 mole of 6.02 times 10 to the 23 atoms of carbon will weigh 12 grams. Okay, but we're going to be using the mole for all of our chemistry, not just carbon. Okay, so that's a bit of a starting point anyway, that you need to be able to use this number and know how it relates to quantities. But I want you to be thinking it's just the same as saying it doesn't mean 12.
So what about other elements?
Yeah. If I have a mole of copper, then I'm going to have that many copper atoms. Doesn't matter now. I'm only counting how many I've got. I'm not worried about what it is. If I could have a mole of beanies, okay, and I'll have 6.02 times 10 to the 23 beanies. It doesn't matter what it is, okay?
So it's not actually even related to mass. It's simply a quantity. Like
That's-
we've used mass to find a number,
Yes.
but in itself, it could be whatever you want. It's
That's
simply a
exactly right.
quantity.
It's
Yeah.
just a quantity. It's just we're counting particles or whatever, beanies. Yes. So we're just using it in the same context as we use the dozen to count eggs or whatever. We're using this to count particles or of anything. Yep. So I'll turn this off now and we'll